Hey there, Alexi. DJ. Okay. I get the feeling I got the wrong resonators. Damn it. I think the ones that I ordered are too big. Okay, these are some chip LEDs that I'm going to use for a new microscope light source, but I haven't yet sorted out a board for it or anything like that. We'll get to that later. They just came in today's supply of parts. So they're supposed to be pretty decent. They're 120 lumens and they are 4000 Kelvin, but the big thing is that they have a 97 CRI rating, so they should be very nice to look at, or very nice to use under the microscope. Give a superior sort of look to the electronics that we're working on. Alright, so these turned up today. These are the SO8 versions of the current meter boards. It says DJ Craze picked up a BK6000 hot air station. I have never even heard of one of those. I'm sorry. Hey, really? But yeah, the resonators, I think, oh no, they're the right size. Oh cool, okay, I'll get to try out a new part then. That's excellent. Just for some reason I thought they were bigger than what they are. These also have a built-in capacitor, so you don't have to have capacitors off the side. I've got a cough. Excuse me. And that is clearly not the job data because there's no job. So we're going to quickly build one of these, see how they go. Obviously it's technically should be the same as the other one, but technically and actually can be significantly different things in life. Hey John, hey Joho. So let's see, we've got our SO8 version. Well, you can't really get the what do you call it, the SO8 versions anymore currently. You can get the SO8 versions. In fact, if you buy any of the INA219 boards out there, they will all be the SO8 version. Even if you see them advertising with the what do you call it? If you see them advertising with the INA219, sorry, the SO8, when they ship them to you, they'll be the SO8. Is that the right one? Yep, Tiny 45. Hey Jose. Alexi, I can indeed do one of these for you. You won't get the first prototype though. I always get the first prototype and then I do a better job and give that to the next person. Alright. Because I always invariably make a lot of screw ups on the first one. Hey Mike Sims, Paul, hey 3X, Keith. Hey, you're actually here, Keith. I'm kind of curious to see how the white goes with just general soldering work. I imagine it's actually very, like a white shirt. It's got to be quite difficult to keep it clean. I reckon these would absolutely have to be put through an ultrasonic cleaner. I wonder if there's a top and bottom on these resonators. I can see there's a layer through it, which will probably be the capacitor implementation. Doesn't really seem to matter. Yeah, the PCBs actually came out a lot nicer than I was expecting. I don't normally really go for coloured circuit boards much, but I gotta admit I thought I'd try the white, and I've been trying the yellow. They seem to be the two colours I don't mind. It can be a bit tricky sometimes working out what's just a bad focus or bad silkscreen. Hello Travis, fancy seeing you here, eh? Not really your kind of stream, Travis. There's no PCHs here. I'm gonna be naughty. Well, all you guys have been kept pretty busy with the streaming the last day or two. I mean, between Rossman, Tim, Phil, myself, you guys have had a pretty full dance card. A little bit uneven on the distribution of solder there, but oh well. Yeah, this is definitely going to have to get ultrasonic. You can see straight away that the flux, when it starts getting baked, goes that yellow color. Noosa Cat, I'm highly offended. I'm demanding to know why. But thank you for being directly honest and hurting my feelings. Hey Ann. Mike Sims, yes, this here, the CH340, is a serial to USB chip. It's a very cheap, simple, but effective one. Travis, of course I've got feelings. I just think they're stupid sometimes. Hey B-Dog. And you have got, oh my. I actually asked a data recovery service business the other day if they wanted any of my hard drives, because as you can imagine, after many years of doing general IT work, I've got a few hundred of them. Anything, you know, the usual 3 1/4 to 2.5s, but I think it's a bit of a plague proportion thing now. So I'm kind of wondering whether I can get any reasonable amount of money for them as scrap metal if I break them down. Hey Tradie Trev. And gadgets. Because there's got to be a couple of 100 kilos of aluminium just sitting there. Hello there, Adrian Belija. Almost didn't see you there. Alright, so we have to take the INA 219 off here and put it on the other board. Funnily enough, it's cheaper for me to buy them like this and take them off than it is to actually get them just simply as a part in a tube at the moment. So if you are planning on using any INA 219s, I suggest buying up these boards, enough of them to get you through until the world supply comes back. We're going to be stuck with these for a little while. I cannot get the INA 238s, or whatever it was that I was going to get. They're just not available currently. Above us, Rendit. Funnily enough, these chips have actually been pulled from something. I don't know what they've come from, but they're not fresh chips, as it were. So even when they're making... So this is like the third board that this chip has sat on somehow. Ian, is that the guy that does a whole bunch of Nordic gold and stuff like that? He just basically gets anything and everything and just melts it down. He's got a shelf full of all the bars of the various alloy mixes. That's not really the best solder job, that one, but that'll do. Yeah, I've seen his videos. Realistically, I should have put down a lot of the passives first, things like the resistors and all that, because they have a lower height than the chips. But because we're doing a single-sided board and it's surface mount, we can actually violate that rule. The rule of doing the lowest height parts first usually comes about from the days of doing pin-through board development, because you want to be able to flip the board over and have the weight of the board push against the part, so that, you know, when it's flush against the bottom of the board. And obviously if you do the high parts first, then when you put the small ones in, they're going to kind of fall back a little bit. So it's really a carryover habit from the 1980s, but you know, which is why I'm not too fussed about violating that right now. Hey Dudumrez. Oh, thanks for the PayPal the other day, Dudumrez. Sorry I haven't replied back yet. This is the trouble. I'm starting to get casual. That's a bad start. There's going to be a bunch of people who can put their hand up and tell you that they've been burned by me starting to get casual with things like that. I think most of those tips I got from the Tricky Dick's Funway guides or something like that. Pretty sure that's where most of those tips sort of come from. And realistically, they are sort of the kind of tips you hear from people who've been doing it for a while. But like I said, it does go out the window a little bit with surface mount. Oh, you're sending the drives for data recovery. Oh, okay. All of mine are post data recovery, so they've had the recovery done and now they're just junk. Englishman in Brazil. Well, I haven't decided yet what I'm going to do. I mean, I might... See, the trouble we've got facing us is that this board here will do the current 20 volts, 4 amps, no problem. But we do have the higher voltage and up to 48 volts for USB-C coming out, and so I'm kind of wondering whether I just withhold development until I can get access of the new chips that I want, which is the updated version of this, which will let me do up to 85 volts. So yeah, it's a little bit of a predicament, because I don't want people buying these things and then finding out that they don't work on the higher voltage USB-C, beyond 20 volts. So people be like, you sold us this and it doesn't even work now for the proper stuff. Oh, and I'm not that good at data recovery for spinning rust drives. I do what I can, but I'm not what I would consider. I don't have clean room or anything like that. Come on, just need to find a tip to get in there. There we go. Why is the board grey? Because it's actually white. It's grey because I decided I would try 50 Shades of Grey board. Is that good enough reason? Does a man have to explain everything? Yeah, Tradie Trev, apparently the new standard will allow up to 48 volts and 5 amps, I think it is. So, and the latest Apple USB-C brick, the 140 watt one, that will actually push up to 26 volts, which 26 or 28 volts, I forget which it is, but anyway, the point is it actually exceeds what this chip will do by 2 volts. And so I was like, yay, I'm obsolete before I'm even started. It's 28 volts, right, okay, thanks, yeah. Ah, it's a terrible placement. Still terrible, and I've got a dry join there now. Mike Sims, I think the thing is that they're trying to make USB-C sort of the ubiquitous supply connection now. And I can appreciate them doing that. I think it is a worthwhile thing. So you've just got this one connector standard that will handle all of your DC power requirements up to, what is that, 200 and, call it 220 watts. Which is pretty decent. So I think that's what they're going for, because if you think about it, 220 watts with that, you can just start plugging desktop PCs almost into that. And let's see. It is a slightly greyish board. I mean, white is very subjective anyway. I just had paint made up today that on first glance it's white, but then if you sit there long enough you start to realise it's got little tinges of green in it and things like that. I'm putting way too much solder down for those. Stephen W, 238 is the one that we're going to go for. The INA 238, which allows me to basically keep almost everything here because it sticks with the I2C connection rather than the SPI. The only difference being is that instead of a 8-pin chip, it's a 10-pin MSOP or VSOP. Either way, it's a flat, tiny chip. Yeah, INA 238 is the one I'm going to use. Where's my 603 caps? There we go. Mike Sims, I do agree. I'm not a big fan of the physical construction of the USB-C. I would have preferred it to be more, well, everybody's heard me say this, but I'll say it again. I would have preferred it to be more akin to the lightning style connection, where you have a solid, a single solid tongue going into a simple receptacle. Not a fan of this whole double the goddamn pins with a weak tongue in the middle of the receptacle. It's needlessly complicated. You'll probably find the power tools will start getting USB-C socket for the battery charging though. And they'll just simply have the charge electronics in the battery. Just so they can jack the price up another $100 needlessly. As if they're not already expensive enough for what they are. Mike, I hope that as maybe USB-C sort of becomes something that's everywhere, I hope that they start putting a little more effort into, how could you say, robust connections. Like ones that can actually take a beating. Just a hell of a lot of external load-bearing parts that keep the load away from the inner pins and tongue, physical load. It's a bit like with HDMI. I mean, geez, the number of HDMI ports that get wrecked just simply because of the cable hanging weight, the hanging cable weight rather. It feels like every 6 months you've got to change the HDMI cables just simply because they've been sitting there out of the back of the TV or whatever. But I do find it a pain when they design these connections and they just simply assume that the connector is going to take the strain. With the MacBooks, I mean, you've got the chassis as a low precision sort of outer limit retainer, but there's still a lot of slop in it. There are some devices that hold the connector quite well. There's some good tolerances, but there's obviously downsides on that as well, such as accelerated wear, but they are out there. Yeah, Daniel, it would have been nice if they'd done that, because it would have been an excellent combination then. I think they probably would have had a lot less resistance to USB-C becoming more widely. I mean, it's on its way now, for sure. There's no stopping it now. But I think the trouble might have been that when Apple / Intel patented that physical implementation, it pretty much, a lot of people were like, well, we're not going to go anywhere near that. But then again, the USB consortium has had a long history of having lust for these inner tongues. I mean, you just look at the micro USB connector. The mini was good, which is why I use the mini all over the place where I can, but the micro one, oh my goodness, perpetually breaking that thing. Certainly Thunderbolt was always very ambitious, but I think the price stayed a little too high for a little too long. And a bit like how, well, I mean, USB was technically always inferior to Thunderbolt, like Thunderbolt 400, Thunderbolt 800, things like that. But in spite of the inferiority, the cheapness is what got it over the line. Mike, no, I won't be doing any kits of this. Kits cost too much money to make. Too much money and suck up way too much time. Like I said, I don't mean any offense by that, but having been there, done that, I do not want to ever do it again. Sorry, I am thinking of Firewire. Thank you very much for that. As I said, half a brain while we're YouTubing and building a kit. Yeah, sorry about that. I was meaning Firewire. If you go back in the video, you'll notice I paused a little bit and I was trying to think of which one I was talking about. Mike, I will be getting the I'll get a factory to make these. The only reason I'm doing these ones is it gives me a chance to get a feel for what I'm working with, see if there's any issues that I can spot, stuff like that. But after the first 3 or 4 of them, you very quickly get the feeling of like, oh hell no, I don't want to do any more, keep them away from me. Prototyping is fun until it becomes manufacturing. Once prototyping becomes manufacturing, it just sucks the life out of you. Hey John Finn, and hello Marek. Gee, I hope this is the right regulator chip. MCP 1703, 3302, I'm pretty sure that's a 3v3 one. Oh, thank you very much for that, Marek. Let's see. $15 Polish, I don't know, what's the Polish currency? Hey, Jane Goy? Ha! Game Joy. Hey, it's again, Nick. Slutty. Okay. That's an interesting currency name. What's this? Take a leaf out of Unexpected Maker's book. He had to upscale because of manufacturing gone full steam. Were they doing it in-house, were they? I'm pretty sure they're all 10Kers. Ah, where's my 10K? I've got a bunch of 100 nanofarads. I don't need those now, I need the 10k resistors instead. Ah, here we go. Oh, Marek, you're the one trying to compile the multimeter software. See, the problem you're running into there is that I never made that Wiki software for Windows. I mean, I might be able to cross-compile it on Linux, but I've never intentionally made it for Windows at that point, and I gave it to someone else. So I don't actually have one of those multimeters on hand to even test the build. Alexandra, I have not actually solved that 1466. I haven't even fired that one up today. I was busy doing some other ones today. In my cart with AliExpress, I have the USB version of the Wiki BC8 one, whatever it was, that meter I had. Oh, that's a terrible job. Yeah, I've got the... Okay, we've got a problem here. Where the hell's my pull-up? Oh, that's my pull-up there. Don't mind me, I'm just talking to myself. I needed an expert opinion. The meters will most likely be for sale once I'm happy with them. Obviously not the ones I hand make. They're just for prototyping. But I'm actually really happy with the fact that I've gotten this far. Hey there, Defcom. Yeah, Defcom, I've been starting to run into it as well. It's frustrating to say the least, isn't it? Very frustrating. Let's see, Jimbo, with this particular meter, it's just, all I do is just drop the register values. I don't do any processing on the AVR, I just simply send whatever the register values are into the serial chip and it goes into the computer, and I let the on-screen display do. Oh wait, you know what? I lie, because I've actually got to process them to put them out onto the LCD panel. I forgot I did that. If I dropped the LCD panel, I could very easily just use a tiny 25. 2K would be more than enough capacity to do it all. Let's see, I'm trying to fix an electrofusio welder. Is that the... Are they one of those things where you can weld metal to glass? Is that one of those things? I know about them, just not a lot about them. But yeah, Defcom myself, I'm running short. I can't get many of the INA 219s, and I definitely can't get the 238s. So it's going to be a bit of a waiting game. Even trying to second source them, I can't find much. Or they want something ridiculous like $14 a chip. It's like, oh hell no. Oh, it's for welding polyethylene pipes. Okay, my bad. let's see. Okay, USB connectors and the shunt. So we're using a 50 milliamp shunt with one that I am going to do for the high voltage and all that. I'll be using probably a 10 milliamp, maybe 20 milliamp. I'm not sure. I'll just have to trial a few. But it'll probably end up being 10 or 20 milliamp. Because once you get over 4 amps, 50 milliamp starts becoming... it gets a little hot. I mean, as it is, this already has to dissipate about 800 milliwatts of heat at 4 amps, so yeah. And while it's a decent size shunt, and you know, there's a decent size bit of flood fill around here, it's 800 milliwatts is still, it's not a small amount of heat. Yeah, Jim, I actually did one of these probably about a decade or so ago, and I also did them for USB-A, but I was always holding off on USB-C because I wasn't sure of how I was going to go about handling the signaling and all that for USB-C. But then someone dropped me a note and said, you can just, all you have to do is the same as you did with USB-A, and that is, you know, cut the V-bus line and you're good to go, and carry your CC1 and CC2 through, and away you go. So it was that tiny piece of information that allowed me to jump from sitting around twiddling my thumbs to actually getting the project done. Stephen, the resistor is within its rating, I agree. I just prefer not to bring it anywhere near that rating. Hey Catherine, yeah, this is the SO8 chip version. The other one that I had was the SOT238 chip version. So like the INA219 on the other one was a much smaller chip. It was more like that size. This here is an SOT23 3-legged chip. And the other one I had was an SOT23 8-legged chip. So it's the same physical body, but it had 8 legs. But this one here is the SO8 chip size, which is probably more humanly accessible. Mike, for these sort of boards, probably only 5 minutes, and then of course you've got to do the drying cycle. Drying on these, I would probably do them the typical 20-minute dry. Mostly because I've already got the oven set up for that, so I may as well just keep using it. Oh, ran out of flux at the end there. Yeah, we've got to flash it still. And I may... Looks like I need some assistive heat on that corner. The flux is helping, but there's just not enough heat getting into that area, and it's giving me Hershey kisses. There we go. Once again, the mask is wrong on there. The mask should have been such that I could, solder direct on there, but instead I can't. They've plated the holes on the inside, but yeah, not sure what went wrong there. Jim, I'm not sure quite what you're asking there, to be honest. At the end of the day, I guess what I'm trying to say is that it ended up being a much simpler thing to do than what I was anticipating. That's all it comes down to. I basically held off doing this for so long because I was anticipating it to be a lot harder than what it ended up being. I did the Gerber, and I'm almost certain that the Gerber did actually have that, but sometimes what can happen is that the place that does the book... Whoa, I just noticed... Oh, right, no, I just realised now. On the new boards I've got the connectors on the same side, and I cross over the signal lines. Whereas on this one, I made the signal lines just go straight through. And I was looking at this and I'm thinking, I'm screwed, I haven't got any pads. I realised it's on the other side. Idiot. Oh well. Jim, I don't know if you saw the previous videos or whatever, this also has graphing output and stuff like that, but obviously I don't do it on the device itself. I'm guessing that's what you're after. You're after something that does it on the device itself. Whereas in my case, I actually wanted the opposite. It's like I wanted just a simple vampire tap to get the data to the PC, and then I did do all the fancy stuff on the PC side. Stick it to Lost in Perspective. Oops, not allowed to have that bridging. That's naughty. I don't know where the flux is going, but it keeps running away from me. That's better. No. That was a good fill there. Since this thing is just surface mount pins, you do have to make sure you try and get as much into the mechanical mounts. Hey James Ewing. Okay, so that's how it actually should look. Not half dodgy like that. Alright, now we need our data connection USB port. And crikey, where have I put those? I have a large spool of those mini USB connectors, but a large spool is no use when you can't find that spool. Gee, I only had it like last night or the night before last. And as usual, of course, it's something that you stumble over a million times and you keep saying to yourself, you know, I really should put that spool of connectors away. And this room is not that big. What's the bet that I put it in a safe place or something stupid? Oh, come on now. That's annoying. Mini USB. I'll almost never put a micro USB on my projects out of pure principle of nothing else. Lousy little SOB. It's going to force me to have to take one off something. And of course after I take it off I'll go, oh there it is, there's my spool. God damn it. Fine, we'll take it off something else. By the way, these are one of my old USB meters that I had. So same thing, yeah, you just got your two USB ports, you cut the bus, the V line, and my voltage sensor and all that's under there. That's got to be a good 10 years old now. Hey Tony W. Joe, yes, it will. The final product will be a mini USB. They're actually not that hard to find the cables for. Worst case scenario, I'll ship them with cables. Although I prefer not to because that is extra weight. If you ever wonder why there's tape on the top of these things, it's so the pick and place can actually grab them. Obviously I'm talking about the robotic pick and place as opposed to the human pick and place. A little warm. Ow. Ow. Yay, I got a bridge. 2 bridges, in fact. This is the upside of using the white circuit board, is you can very easily see that there's a bridge between the pins, and now there's a bigger bridge. Just keep feeding it flux and heat. And cleared. We'll give it a scrub down. It's not going to be as good as an ultrasonic clean, but at least it might remove some of that horrendous sort of old pea looking stain. So this is the one that we have that's already working. We're going to take that out of commission for now, as we start the process of making sure things don't go bang. Okay, the LED works, so therefore it's perfect. Don't need anything more than the LED working. Beyond that is an overkill. Micro will be about half an hour away. 10:30 is his time. Oh crap! Forgot that I left that camera on. Oh well, you can all just suffer. Scary dude at my shop, there is indeed. There is most certainly indeed. Oh, so that's flashed. Let's see. Let's see if it actually comes up. Yeah. Stupid micro USB. Alright, bad start. That's not coming up. Oh, I know why. I know why. I think, maybe. Possibly not. There was a modification we forgot to make on this, and that was we haven't set the address pins for the INA. Now they're different to the other one. I just can't remember which one. I have to look at the data sheet. Come on, Texas Instruments. Today. And it's 7 and 8. It's these two here that need to be grounded. Shame, I'm going to have to sully up this beautiful board. Ah, I'm a moron. That there's ground, so I can actually just bridge all three. Wait, that makes no sense. No, Paul's got a problem here. Have I completely botched up the design of this board? I get the feeling that should be the other way up. No, we've got a problem here. Oh no, I know what's going on. I was looking at the SO8. Okay, so this is in plus, in minus. Let me just check the other board. Nope, you're not boards. Please stand by while Paul has a moment of crisis as he thinks he's stuffed something up. Okay, all good. Okay, so yeah, plus, minus, ground, voltage. These are the address pins here. And I don't actually have a ground flood into that area. I don't think, or do I? Oh yeah, actually I might. Yeah, the chip's already programmed. I do not have a ground flood there. That's annoying. Very annoying. Very, very annoying. So it's not quite as elegant as the one that we did the other day. Okay, fair enough. Can't have everything our own way. Yet. We'll get there. Give me a bridge. Damn it. Give me a bridge. Oh yeah, that's a bridge. Now, I just need a 1206 000. Triple O. Nope. 000 1206. Yes. And it will look sort of professional. As long as it doesn't fly away. Well, it's not the prettiest, but it's pretty good. And trouble is I have to clean it again. Alright, still nothing. I'm trying to wonder what it is that I've missed. Because the other issue we had when it was the LCD wasn't coming up due to the enable signal not being asserted, that was flashed into the chip, so right now the chip should be the same. One thing we can do is we can reflash it and see if the display comes up with the full contrast, and if it does, then we know at least the display is functional. Hey Patrick. Okay, so the display definitely comes up. Which makes me suspect that there may instead be a problem with the INA. One. I've just checked and the USB device is actually showing up, so that's a good start. And we actually do have data coming through. If I plug this in, you'll see it fire up. But there's, yeah, like I said, there's just an issue with the display for some reason. We'll get to that in a second. It could be maybe I've picked the wrong flyback caps or something. Yeah, there you go, you can see it's working. The LCD is the correct way around, yes. So you can see it's charging this laptop on the screen above, 1.2 amps, 1.3, etc. So we just have to find out why the display is not working. No heater voltage. That's almost possible. And missolder something? Oh, it's probably because of that. See how it's not plugged in properly? As Creature said the other night, this really isn't the correct connector for this type of cable. But it's the only one we have at the moment. Okay, so here we go now. No, the screen is actually fine. It comes up with a full matrix display. Or at least it seems to be, should be. So I can then fold it back like that. Kind of wonder whether it's not getting its flyback voltage. But it did come up. Why are you doing this to me today? Alright. This is where I start. This is where I start comparing the boards. Old versus new. Well, I shouldn't say old versus new, it's more like A versus B. So we've got these two coming down, and those top two, yep. It's a little hard to see, but those two coming down, yeah, see that hasn't been changed. And that should be 1 microfarad and 100 nanofarad, and they're 1 microfarad each. But like I said, yeah, the it's behaving like it's not getting the enable. Did I attach the enable on this board? Okay, this is the enable here, this one that goes over and goes to pin 5. And as you can see, it is present there. And again, goes to pin 5. I mean, yeah, the thing is, that is actually working fine, because we're getting, you know, when I was running it just before, we were getting the data. But for some reason, it's like it's not getting enabled, and I don't know why. Like I said, maybe it is just a shonky... Did I get the right resistors here? That's the only other possibility. Yeah, they're all 10Ks. Okay, 10K is good. I'll pop it out, flush it out, see what happens. I mean, like I said, it's not the greatest connector, but you can see it's smushed them in pretty hard. Well, we'll try another display. But like I said, when I flash the AVR, that display activates. Yeah, that's right. Everything works except for the display. And the display shows life when it's connected with the flashing. So we know the display does sort of technically work. It is capable of... now that's well and truly effed up now. After that delightful slip. No. Fantastic. Here we go again. Alright. Back to the firmware code, and what we'll do is we'll just make it so it generates something on the display and nothing else. This is why you should never get the false belief that it's going to be a simple process of just changing a chip. It never is. There's always something, and in hindsight you find it's something really stupid, but while you're chasing it, it's frustrating as hell and makes you rip your hair out. Ah, g'day Adamanti. Did you confirm the voltage regulator being 3.3? Good point, Mike. Good point. Thank you for that. I'm pretty sure it is, but it is a good point, and based on the LED brightness, I'm assuming it is. What are you up to, Graham? Shouldn't you be working? Yeah, 3.3. And yeah, the ribbon is the correct way. Like I said, it's behaving like the enable is not being asserted. So what I'm going to do is I'm going to go to my source code, go all the way back up here, and we're just going to enable this little section of code so that the only thing it does is display that and nothing else. Programmer is alive. Bzzzt. Flip me, eh? Clearly I'm doing something dumb. No, Creature, all I did to get this layout was to change that chip and reroute it. And it doesn't even share a common line with the display. I have a feeling maybe my capacitors are wrong, but then again I am getting... let me just measure voltages and see what I've got. There's no clock into here. The only clock we have is for the USB serial, and that's working fine. These I2C chip-on-glass units, they're all self-contained. Five. Okay, we've got 3 there, 3 there, 3 there. We've got 3 volts everywhere. Everywhere it should be. What the hell's going on? Ground is connected to... Let's see what my assert pin is set at. And that's at 3 volts, so it's definitely been told to turn on. Oh man, this is just weird. When I say 3, I mean 3.3. Yeah. Let's say we do this one. So I mean that's working just dandy fine. So why is it not working dandy fine here? Like I said, it'll be something truly despicably dumb. I just don't know what it is yet. Now, for those of you who are going to say, why don't I take this display, put it on here? I would, except for the fact I've got double-sided tape holding that on, so I don't want to mess with that. Well, I'd imagine it'd be a veer problem if... Now, Now, the downside of the white circuit boards is that it's actually a little bit annoying following the traces. So there's basically only 2 traces of any concern, and that's this one and this one, because they're SDA and SCL. And I said they're going through here and here. Let me just check. I must have voltage here because the AVR reset pull-ups here on the same rail, and it's working fine. Oh man. So basically it's these 2 lines here. The only thing I could possibly think of that might have happened is perhaps, what if clock and data are actually reversed? Like maybe when I changed it over to this and rerouted SDA and SCL, maybe I actually swapped them here without thinking about here. I think that might be what it is. Okay, so that's data and that's clock. Data and clock. And on this one, that's data and that's clock. But it must be working because I haven't changed the firmware, and the AVR would be, yeah. Anyway, so data goes to pin 2. Data goes to pin 2. No, can't blame that one. That was going to be my hope, but then I realised it didn't make sense either. Should oscilloscope see what's happening? Yeah. Well, creature that goes to the same place. So what have we got? Let's just compare here. Let's take this outer one. Easy to do it, continuity mode. Okay, so data pin. Okay, data pin on the INA is the third pin on the display. Data pin on the INA, third pin on the display. Yep, can't blame that one. And like I said, the enable pin for the display is actually being asserted, so unlike the previous time when we didn't have a display, that is actually covered. One board can have a manufacturing fault. It can, yes, although I'll be very surprised at this sort of coarse type resolution. But, well, I mean, let's just test the continuity of the I2C lines. It's a clock. Yep, pin 2 there. Okay, so we do have full continuity from this chip to this chip. These are 10Ks. Like I said, the I2C seems to be working fine because, you know, we're getting the data off the INA. If there was a problem with the I2C bus, we would not be getting data off this and wouldn't be going to the PC. At least in theory. I am going to try change these two caps. They may, I don't know why I'm going to think of that, but I'm just going to try it anyway, because I did pull out ones that were higher voltage than I normally would. Creature, this is really slow I2C. This is like 100 kilohertz I2C. Why do you want to waste all the energy by having 4.7 active pull-ups? Think of all the electrons you're sending to an early grave. interesting to note, it didn't actually fire off the it didn't go all blocky for some reason. That did. Alright, I'll be right back. I'm just gonna go get a printout. Oh, this is the previous one. C7 and C6. Yeah, so 1 microfarad, 1 microfarad, 1 microfarad, 100 nanofarad. That's micro. Alright, I'll just go sort out micro. Go get a printout and come back. Ah. At least once I got the printout, I can make a better comparison. Alrighty. Okay, you bunch of chocolate teapots. Sorry about the delay, I had to do various pit stops. Had to get a drink of water, visit the wife, have some chocolate, wash my hands, all that sort of stuff. Essential things. So you want me to check that I don't have a floating ground? Yeah, it's possible. Normally I'd check to make sure that the design rule check doesn't come up with a you have 2 nets left to populate, but you never know. You never know. Ah, I forgot my paperwork. Okay, I'll be right back. It could be a floater. So this is the SO8 version. I guess the easiest way to check to see if we've got a floater or not is just simply to do a continuity test. I won't even use that. I'll just compare these two. Yes, the programmer could be linking the rails. It's kind of like how we were getting blocks with the previous fault. Anyway, okay, continuity is active. So there's our ground. Okay, so that ground's connected. It's the only ground for the display. How about this one? That's connected too. So unfortunately the floater theory isn't happening. It was a reasonable theory. Not bringing out the oscilloscope. Good God, no. Okay, what I will do though is I will power this myself. But we know it's getting 3.3 volts, and there's enough decoupling going on there to keep a divorce clinic happy. Hey, Ron Rogers. Okay, what we'll do is we'll compare the voltages we see on this one compared to what we see on this one. And yeah, I'm not bringing out the goddamn oscilloscope. That thing's buried somewhere. That thing is purely a token, yeah, a token piece of test equipment. It's not actually used. It's kind of like having a sports car. It's there to show you success level, not there to actually be used. Alright. So 3.2, 6.4, yeah, which is right. 1.6, 4.8. Alright, so yeah, see these two here, they're used for generating the voltages required to actually cause the LCD to work. So let's see what's going on here. You sure you correct the bridge the... Well, I hope so. I probably didn't, but I hope so. Actually, no, I must, because I am getting data from it consistently, even when it's switched to 20 volts. So yeah, that must be okay. 3.3, 6.5, 1.6, 4.9. And guess what? Who knows what's going on with the mysterious magic of Mr. Daniels? It's working. What a pain in the ass. You're not supposed to work. That's unacceptable. Graham, I'm angry for all reasons. Or should I have just said yes? Okay. You see, now it's screwing around again. Let me probe it. Let me probe it. We must have something floating here. Something's got to be floating, because often when you do this sort of thing, when it comes to life, when you probe it, that often means that... So what, 6, yep. Oh, now we've got millivolts there, see? So we've got 3.3. That's all over the place. And that's way low. 3.3. So something's happening with the boost drive for the... Okay, let's resolder some connections then. It's a quantum circuit. You know the screen kind of works. I'll check continuity. Well, creature, obviously the code works. Maybe I'm just sitting on the borderline or something with regards to timing. But I've usually got a timing delay in there to initialize the screen, as per the... what was it? I'm just going to mix up the code a little bit, see if we can get something. Hey there, Unimar. Isn't it sometimes it comes good and other times it doesn't? Yindi, why are you feeling crook? What's your catch this time? COVID. Why are you going catching COVID for, you idiot? What possessed you to go out there trying to catch COVID? That was a little bit silly. I'm very sorry to hear you have that. Now, of course, Creature, you're screaming about timing there, but you got to realise I've been using this code block since, well, for a decade. So, you got to understand that it's proven code, so why is it misbehaving now? That's what I want to know. Not with that INA. Yeah, but you see, I'm not actually doing any... like the code I'm trying to get to display on the screen now doesn't even talk to the INA at this point. I've blocked out all that. Power rails. It's going to be something dumb, that's for sure. I know that much. How long you been suffering the COVID there, Yindi? Fixtech, this was the original code. Okay. Yeah, see, and then it doesn't that time. Oh, now it does. Alright, okay. Stick another 2-second delay in there. Yeah. I hate it when you end up doing bodgy stuff like this, because it always bites you in the backside later. Always. we go. I'm not happy with it. I will have to diagnose that in greater detail later. Maybe it's a dodgy INA, as in, oops, crap. There's something ain't right there. That's not reading the right values. Oh, there we go. It's because it was the wrong way up. Alright, that's the right values. Stop sliding off, you lousy. Okay. No, everything looks good there. It's not missing the first digit, that's just the chevrons showing which direction the current is flowing. And in this case, on your view, it's going from right to left. Why are the values what? Different? What values are different? It looks like screen and LCD are matching. So yeah, if I put that cable there and so on, the chevrons will point the other direction. When it comes to the production version, I will actually make it so it loads a custom icon rather than just a normal sort of greater than, smaller than type arrow, just to make it look prettier. The done res, I honestly do not know for sure. Oh, Catherine, they were dodgy because what was happening is that there was kind of a power coming from this cable being present, just picking up random noise. And this cable was not orientated in the correct direction, top-bottom orientation as opposed to left-right orientation. I don't know why, but with these connectors and with the ones that I had on the other units, you have to get the orientation of this cable correct, as in top-bottom orientation, which is why I've got color markings on them. It's just this one here that matters. It's the input one that matters. I can flip this one and it doesn't matter. So like we can go to the red side. Nah. Okay, looks like I get to bite my... God damn it. What's going with this cable? This cable should be better than that. It's a genuine Apple cable, for God's sake. Huh? And I've tied both sides of the V-bus line and everything. There we go. Yeah. Yeah, so for some reason it gets picky about the orientation, and yet I know on the other USB meters you get, the USB-C ones, it's not, so I'm not quite sure what's going on there. It boggles me. Like I said, if you look at the... Where is it? If you look at the board, I'll just unplug this for now. I'll shuffle it off to one side while it just plays around with itself. We'll give it some privacy. Creature, I actually made it do the init sequence twice for the moment. Anyway, if you look at the way I've done, I'll actually bring it up here so you can actually see both at the same time. Actually, probably another yellow one would be better, since you can actually see the traces on the yellow one. Anyway, you can see that, so this is the V-bus pin pair, and so you can see I've actually tied them together to go through there. And so you would think that it will work no matter which way you put it. And CC lines and the D plus D minus lines, they're routed through as well. So I'm a little bit stumped as to why this is the situation. Maybe I'm incorrect on the way I'm doing the data plus minus lines, but if I cut them, it doesn't make any, it still does it anyway. In fact, the first incarnation doesn't even have the data lines, and it also does it. The connectors aren't cheap Chinese ones. These are actually, okay, I guess they could be, but I actually got these connectors because of the fact that the ones I was originally using were, yeah, they just had V-bus, ground, and CC1 and 2. So I got these ones which would give us, at least data positive data. Oh, yeah, so you can see there's a bunch of possible pins missing in there, but it's the same top and bottom, so I don't know, kind of stumped. I will say this much, it doesn't really give me a lot of confidence for carrying high current on those pins. At least as it stands now, it's usable. Yeah, it does the job. It gets the reading right, and of course I get it on display. So that's what matters most. The connector looks like it only adds half the set of power plus double on the power. Well, that's what I was thinking, Creature, but I guess I'm more than happy to leave it like it is. And just simply put it in the FAQ of the device. If you can't get the power to run through, just try flipping the cable. It's a feature, alright. Graham, you want one of these? I'm not actually going into production yet. I've got a few more things to sort out, not least of which is the actual supply of the chips that I need to make these. I have a new variant coming which uses a better current voltage sensor chip that will handle the very latest USB-C standards, but unfortunately they have a half-year lead time, so yeah. Was this a reset button to be put on so the cables don't have to be removed and installed excessively? How do you mean by that, Sonia? I mean, the only reason I'm doing a lot of cable chopping and changing at the moment is just simply while we're debugging it. But once it's set up like this, once you've got your cables orientated, then you would really only be swapping this, disconnecting that one, plugging that back in. So, yeah, I mean, certainly, state your case. There you go, state your case. What I did find as a different thing is that I did need the data plus line, the data lines, I think, in order to be able to do the iPhones. It's like I'm doing this here. Like this is a USB-C to Lightning. There we go. Yeah, it's not a very good charge rate going to my phone. I think my connector's dodgy. There we go. It's better. One side of my USB-C port on my iPhone 7 is a bit dodgy. But there you go, you can see you can use it for the phones as well, which is nice, because previously, I mean, I suppose you could use the other ones. It's going to be a handy device for me to have here in the workshop. CC1 and SBU1 are not the same as CC2, SBU. Somehow they want to be able to detect the orientation of the cable. I guess maybe these are just more meant as very simple. I mean, these are only, I think they're 12-pin USB-C connectors. So I guess they're sort of saying, look, if you want to have simpler builds, use these. Eglin. And I guess that's what I'm going for, because quite frankly I don't really care to route 24 pins and go through that sort of mishmash on a two-sided board. And like I said, once you have your orientation set up, then you're set. And certainly, put it this way, I'm not compelled, so therefore I'm probably not going to do it. No, the iPhone does not have a USB-C port. Rather, it's this cable. The cable is a USB-C to Lightning cable. So, one thing I found interesting, this cable actually draws 3 milliamps. So plug the USB back in. And we watch the charge current go back up again. Route all the USB-C pins from A to B. Bro, no, actually, they are the same project. It's just that this one uses a different form factor of the INA 219. This uses this SOT 23.8 and this uses the SO8. That's the only actual difference between the two. It's an interesting creature because, you'd know from all the projects I've done with the model aircraft and stuff that definitely initially, when I was getting used to these displays, that's how I ended up with this sort of bit of a convoluted init sequence. And it's been fine until right now. Until right now, it has not given me any grief. And now I've got to go along and give it a push with... I'll just make it initialize twice and it comes up good. It's just weird. Maybe the SO8 INA 219 does something different on the bus. Maybe it tries hijacking it initially for some reason. I don't know. But yeah, run it twice and it works. Can't you put Francis, I actually did spin a board with both footprints last night, but then I decided that but then I decided to drop it because I want to go with the INA 238 chip, which will handle the much higher voltage of the 45 volt USB-C standard. So basically these are never going to go into production, or at least I don't envisage them going into production, because they will only handle up to 26 volts, which doesn't even cover the 28 volts as the new Apple 140 watt brick. If I use a 140 watt brick, I don't know what will happen. It'll probably upset the INA quite a bit and make it go pop, I guess. But so yeah, they're just going to get scrapped ultimately, and I'm just going to wait for supply of the INA 238 chip. Is it 238? Anyway, I got to wait for supply of the other chip, and that's going to be a long wait. Why not use the small color screens? Because I actually hate them. You see, on the video, you can read that very clearly. Okay, you've got no trouble at all reading that at pretty much any angle. Let's plug this in. Okay, right now that is displaying information. Can you see it? No, you can't. And that is why I use reflective LCDs like that, because they're highly visible in any light. I mean, don't get me wrong, it's really quite neat and cool that they have these OLED displays, and there's so much information you can pack onto them. It's impressive. Unfortunately, after a while, you kind of get sick of squinting and like doing this, trying to cover it up so you can see it in the daylight and things like that, and you find yourself falling back to the good old reflective LCD. And I suppose, though, for me, I do also have the application here, which is really what the primary purpose of this design was. Turns into the one eye for the microscope. Yeah, the one eye system, yeah, that's Rob Brown and a bunch of other people working on that. I believe they're actually looking at using open board data to try and help move things along. I'm not involved with that project at all. Marek, probably not right now. I mean, I could do a production run with the SO8 version, like this particular version here. I could do a production run of it, say 100 units or something like that. But I feel like it might be a bit of a disservice to people, because when they do encounter a like the 140 watt brick, or they encounter higher voltage, it's not going to work. So are people going to get angry at me or what? Christian, the 10-bit versus 12-bit versus 16-bit, realistically, for the sort of stuff we're doing, 10-bit is vastly ample. The real problem, though, is if you want to do what the INA does in the AVR just by using the ADCs and things like that, which I've done in the past. Some of the iterations of this meter were done using exactly that. You just read the voltage across the shunt, and you'd use the internal multiplier in the AVR to do it. But the problem is that when you're doing high side voltage readings, it gets weird and tricky trying to do that. You basically have to use a flying cap most of the time. So what you do is you put a little capacitor across that shunt, you get its value, and then you detach it, and then connect it to the ADC that is on the rails more down where you are, 3 volts or whatever, and you measure that voltage. And once you've done that, you reconnect it back. And you just keep going back and forth really quickly. And that's how you can get away with such a large common mode between it. Like the chip that I'm going to be using will do up to 85 volts, I think. Essentially, it's limited, I think, by the switching MOSFETs, whatever they're using. But the INA just makes it so simple. You've got this one chip, you just read off the values out of the register, and then send it up to the serial port, and you just walk away. No dramas. You like the beard? Oh, yes, my wife prefers it if I don't shave, so given that she is the boss of everything, I will obey. But like I said, the resolution is not a problem. 10 bits more than ample. 12 bits a nice bonus. 16 bit is massive overkill, and I think there's 20 bit ones, and that's 20 bit. You're really getting into the area where as you move your hand across the board, you will register that in the ADC. I know because I've got a project that I did, and it was using a 24-bit ADC. The first 3 bits are basically just complete junk. The only thing you do with those 3 bits is you just keep them for sort of like a statistical noise averaging. and then 21st bit you're starting to get some sort of consistency. But yeah, if the temperature varies, something shades the box, or your hand moves near it, even with a bit of shielding and everything like that, you will pick it up. Yeah, we call it super sampling, but that's kind of make us just feel better. But anyway, so yeah, the ADC's got more than enough. Realistically, for what we do, the first decimal point for the voltage, like 19.9, that's more than enough for us to really care. We don't need much more than that. And with the current down to 10 milliamp, sort of precision is ample. Alright, so that's the meter sorted out. Now I'm going to disconnect it. Maybe I need to tie that display onto the back. So I'll get some double-sided tape again. Peter Newman giving an excellent input there that I can't repeat to you. Where the hell's my double-sided tape? Graham, if you're still around, I'll send you a message later. I'll have a chit-chat with you about it. Oh, that was a pretty good guess. No obligation. Yeah, I already know there's no obligation with you. I mean, you're a crazy person living in the UK who condemned me to Australia. I'm sure it was your elders, or certainly your companion there. I'm sure he would have been quite likely to sort that would have said, send them to Australia. Let them suffer for stealing that loaf of bread. The carrot dog's probably sitting there like going, I wouldn't do that. Okay, so, well, that's actually not a bad looking thing. If I wanted to package this up properly, I would just, I've got some heat shrink. It's not the thick stuff, it's more just sort of, it's not the stuff you normally heat shrink cables with. Like usually after about 30mm diameter, I find that is a bit too heavy on a lot of these devices. But the stuff I have, it's used for shrink wrapping batteries quite often. And I do not have any. Actually, I think I threw out most of it. It'd been here for like 15 years. It was probably time. Hey, Momo. Is he being difficult? He's crying. Milo's crying. Okay, hang on there. Mo, what?
Getting all excited because you're coming out.
Yeah. Come here, Mo. Come on. Come say hello to the people who don't like you. I'm just kidding, they all love you. You big sookie bum. He doesn't like it when Daddy's in the office, because he can't come in and annoy me. Isn't that right? Come on. There you go. Look. See? Sticky beak. Have a sticky beak. Yep, he wants out now. He's like, yeah. Thanks, sweetie. No, that is Milo, as in like the drink Milo, as opposed to Micro. The diabetic one, that's Micro. He is a tuxedo cat. I just realised that camera is active, so I better talk to it. He's a tuxedo cat, as opposed to Milo, which is a sort of a 3-color tabby. Is your chair a Herman Miller? No, I'd say, I don't know what it is. No, it's a Pago. Pago meaning cheap from Officeworks. Yeah, Milo is a very tasty drink, but it's not a good drink to have. They sell it as giving you energy and things like that, but basically that's just because it's full of sugar. It's sort of like a malty, chocolatey sugar drink. That's the best way I can describe it. Okay, so I'm not going to be able to produce any more of the yellow ones. The only ones I can do now are the white ones because of the SO8. If I wanted, yeah, the yellow ones are the SOT 23/8s. So I don't have any more of those SOT 23/8s. I thought I did. I was mistaken, which is something I seem to say a lot lately. Stick them in there. I really want to try out these LEDs. These are the 97 CRI 4000 Kelvin ones, and I didn't bother to design my own driver for it. I just bought these. These are LED driver units, just in the sealed containment. Maybe I'm getting lazy, I don't know, but for me it just seems easier to just buy one of these bricks. So this is a Recom RCD 24035. So this will give me up to 350 milliamps, 2 to 35 volts, and yeah, you've just got a couple of basic pins down here, and they're cheap. They're like $3 or $4, I think it was. Stick them on the circuit board. Put a resistor pot for controlling your brightness, and then connect up your LED chain. But I've got to create the LED chain first. Hey there, Pedro. Tony, I already do that. Yeah. Okay. Yeah, these are 120 lumens. Just take one out. And I figure I probably really won't need more than about 6 or 8 of them. The only reason I would ever add more is simply to try and minimize shadow casting. But they have a fairly wide emission angle. I think it's about, what is it? No, I can't see it. Anyway, it's a fairly wide emission angle. So I'm figuring that, if I get, say, 6 or 8 of them around a ring, that the shadow casting shouldn't be too bad. But it's one of those things I'll just have to experiment with. Cooling them's going to be the fun thing, but I'll try and explicitly underdrive them. Rather than trying to squeeze 120 lumens out, I might actually stick it to sort of like more like about 80 lumens, keeping it about 3/4 of their maximum capacity. Improves the longevity and minimizes your thermal issues. I've got 100 of those to play with. What brand? They are Bridgelux. Yeah, Bridgelux 97 CRI, 120 lumens a watt, 4000 Kelvin. I could have got higher Kelvin count, Kelvin temperature, but I do like 4000. I find that 4000 to 4500 I'm happy with. When I start going beyond that, although it looks short term, nice and bright and feels lively, I find it to be rather fatiguing. Just closing up some boxes here. Trying to see now. I've got to try and fix some machines again, apparently. Yeah, I've been looking at aluminium core PCBs. I guess I've just got to get around to doing it. And I'll have that driver module off as a separate unit here. So I'll simply have like a little circuit board that will have, I don't know, I'll come up with something anyway. but I won't have the driver module actually on the LED ring itself. I want to try and minimize the width of that ring because, quite frankly, I'm getting sick of my hot air striking it all the time. You definitely lose a lot of angle, the ability to do your work at a certain angle because of the large LED ring lights. Okay, I just need to put some electronics away. Well, I guess we'll try and see what we can solve with that bloody, what was it, 4066 from last night. Instead of falling back to that whole, oh well, you know, I'm just going to replace the TriStar, or, you know, just that whole mentality of not actually try and work it out and just please bro my way through it. But I really cannot find any other cause. But what's odd is that the SMC, the diode mode for the lines is perfectly good. So that's why I'm kind of hesitant about it. Yeah, Tradie, it is a nice combination, the 4K. Like, so sometimes you feel like you do want a little bit more white in it, like something a bit hotter, but 4200 is probably fine in that case. But I find overall it's something you regret if you go too far. Check all rails. Well, the machine boots and everything like that, it's just got a sensor issue. And that's why I'm thinking it's SMC, because we fixed up the DC inboard, we did all that stuff. Where am I? Yeah, we checked here, and yeah, we didn't have much luck. I'll check actually up the top here. Try a new track. Well, it does it even without the trackpad cable, but in a different chassis. But I'll go double check that anyway, just in case I'm being stupid, which wouldn't be the first time. Anyway, I'm going to check the these are the two pins here for the temperature sensor from the fin stack. And I just want to see, there should be 0.7, yeah, 0.72, 0.72, so yeah, it's not the connector. Mr. Miser, what are we going to do about your name? I'll get my test chassis out again. Always good to have a known working chassis. You can eliminate so many false leads with that. Okay, it would help though if my chassis was intact. It's how long it's been since I've actually had to pull out a 1466 chassis, is that I've just realised, you know, it's not even intact, that one, so I've got another one that I'll use. Let's see, 2012, nope, that's useless as anything. Let's see, display works, 3437, that's okay. We can use 3437 chassis for 165s, there's no drama with that. What's this? If you remember correctly, the CC pins need to be crossed over. You talking about the USB-C stuff? I'll have a look into that, but as far as I could tell, there wasn't any crossovers mentioned in the implementation guides, but you know, I could have missed it. As was mentioned by a couple of people though, those connectors lack a good number of pins, so it's entirely possible that they're just simply unidirectional connectors and that's the end of that. Miles, yeah, that's why, yeah, a lot of people have said to me, why don't I use the bent nozzles and things like that? It's because you lose so much heat in it due to the turbulent nature of the air once it comes out of there. If they did the bending of the nozzles as a curve rather than what they like to do is, it's, if I wanted a bent nozzle version of this, I would actually get a pipe bender. Fill this up with sand or whatever, and then bend it down to whatever angle I want, be it 30 or 45, whatever, and have a nice curve in it. Then at least it's got a chance of retaining most of its heat. But when they just cut it and install it at 45, it's a complete and utter cluster, because the first thing that happens is all the air just rams up against the one side, heats up that area, and it just like bounces around. It's a complete waste of energy. And as a consequence, you find you have to increase your temperature or airflow. It just doesn't work out well. Yeah, no, I definitely don't use the bent ones. They send me crazy, those things. I have bought them because I thought, oh, okay, it's worth a shot. But I think I used them for a week and basically just threw them into the trash. And again, as I said, if they used a proper bend, or circular bend sort of thing, curve, I would participate in that. Let's see. Maybe we'll get lucky, and maybe this is actually just a dodgy trackpad, and it worked for just the time that I plugged it in. Wouldn't be the first time. That's what I hate as well. Is you've got to sometimes plug things in, try things multiple times before you have the win. Let's see. Okay, we're not even getting MagSafe there. What's going on? I'm not getting the light. That's why I'm. Oh, there we go. Bong. Yeah, Graham, if you're using curved tips, those 45 angle ones, you will struggle with that. For things like VRAM chips and things like that, I would not use anything less than the 9 or 10 millimeter tip that they supply, the straight one. That booted faster. I'm almost certain that booted fast. We'll find out, because once we go in here and we see what the fan spin rate is, if it's only at about 1,000, we know we're good. If it's at 6,000, okay, it's only 1,200. Bloody hell. So we do have a chassis issue. We have a chassis issue, and somewhere amongst my stupidity last night, I actually almost missed it. Well, I did miss it, because I was too busy using brain cells thinking it can't be the SMC, because the SMC values are all really good and it looks good and there's no corrosion, and I've fixed up other things. What the hell could be doing it? So let's have a look at their trackpad. Yeah, preheating does help as well. Even if you only like preheat to 150 or something, just being able to have that heat soak goes a long way. Tiredness, I would certainly agree with you on that. So have a look at the actual cable end. I did not spot that. Son of a bitch. I'm embarrassed to say that that is not the first time that I have forgotten to check that cable. I'll go get a replacement one. I think that's the second time, I'd say, in 5 years I've been caught out by that. As embarrassing as it is. The stupid thing is I should have known that though, because when I looked at the connector last night, for those who are watching, I've commented like, oh, there's corrosion in it. Right, just going into the secret room. The only trouble with having your workshop in your property house is that you tend to not have everything all in one big like flat open area. Instead you've got bits and pieces scattered all over the rooms, and you lose a lot of time from that. So I've got a bunch of 1466 trackpad cables. Make sure I've got the right one, which means I've got to put my glasses on because I'm blind. So this is 1604 593, 1604 593, 1604. Yep. Nice thing is this one's pre-folded. Often you get them and they're not pre-folded, and you've got to fold it yourself, and that's a nuisance. But I think I got these. These came from AliExpress, so they at least did the nice thing of pre-folding them for me. That's nice. Not sure what to do about that. It's not likely I'm going to accidentally use it. Cough, cough. Alright, stick our DCM board that has the oversized connector on it. Hey, it works, and it saves the person $80, or actually probably more like 90 now. The camera's kind of skewed off a bit, or is it just me? Yeah, Graham, at least you've actually got a decent hot air station now. And did you upgrade to a Hacko soldering station as well? Because I know that, I know Vince did. Thank goodness for that. The poor guy was struggling so much with some of his previous jobs. I know he didn't want to, on the grounds of, he's trying to just sort of keep it, his work, in the realm of what general everyday people can do. But certainly for the hot air, these days, everybody can afford a quick 861 or a Atten. The Hacko, maybe not so much, but at least you can get the Hacko clones. Oh, you got a pine seal. Oh, that's right. Yeah, I see you've been using. That's why I was getting a bit confused, because I know you're using the tips. To be fair, that is really the main part that makes them so nice, is the fact that I've got those cartridge tips with the heaters built in. I'm going to plug the camera in just to make sure it's not playing any silly buggers either. I'm kind of curious to see how you find the handling of the pine seal versus, say, a Hacko handle. What I would really like is if they made a power unit that you plug the Hacko handles into, and it still does a good job. I suppose that's what the fake hack hose are for. Okay, that's that. Mike, yeah, the one I've got right now does have that vortex in it. Honestly, I don't know whether it's more BS than good. The one thing I don't like about it is the fact that it whistles. I kind of prefer my stations not to whistle. I understand the principle of what they're trying to do, as in, you know, by twirling it around, they kind of mix it to stop any sort of localized hotspots or stuff like that. But I think it's probably just more marketing BS than reality, for the most part. That's my off-the-cuff take. I could well be wrong on that one. Okay, so we're back in the client's chassis. Yeah, I didn't really notice any significant effect. I was perfectly happy with my quick, and I gotta admit what was the reason I did end up? Yeah, there's some things I like about the At and some things I don't compared to the quick. I'm really not a big fan of the button on the handle. I mean, I understand it's kind of useful, but I feel like it's more annoying than anything. On the other hand, I like the fact that I can change the settings of the temperature and air while it's still it's still holstered. Whereas for some reason on my quick, I couldn't change the settings while it was holstered, and I found that quite annoying. Okay, so yeah, we're all good now. Let's run the Valley and see how that goes. Oh yeah, that's right. Yeah, the quick was starting to lose its power because the element was getting a bit old. I would actually love to one day reprogram the quick so that I can add those features that I want. But it's probably a project a little beyond my abilities at this point. Yeah, Miles, I'm glad to see I'm not the only one that found that very annoying. And yeah, the quick lets you do that, but I wish the quick didn't have the damn button on the handle. I wish it was just a case of you put it in the holster, it shuts down. You take it out of the holster, it fires up. I understand it's a bit of a safety feature in case it accidentally gets knocked out of the holster, fine. But I still don't like it. It'd be nice at least if I could disable it or something. Okay, so we're doing 20, 30 frames per second, which is not bad because this is actually a 1.6 gigahertz. It's not a 1.8. It's a 2015, yeah. Temperatures are good, in the high hundreds. See what the battery's like. Hey, B-Blood. Let's see, it's 2017 battery. Okay, and it's about 90% left of it. Fair enough. Now, given that there was corrosion through that trackpad connector, it's going to be an idea for me to test the keyboard. So I'll use my software. Let's do the thing that only a genuine Mac keyboard can do really easily. Okay, that works. Escape, yep. Caps, yep. Okay, so that's all good there. suppose I should check the SD slot as well while I'm at it. Surprising what things can not work when you least expect it. Although I do find the SD slot, sometimes you've got to jam it in twice. Like now. I think because they get used so infrequently that they form a bit of corrosion on the top. This is looking a bit not good. I'll find another one, just in case that's a dud stick or something. It's not the stick I normally use, I don't think. Yeah, that's ominous. Ah, there we go. Yeah, it was just corrosion. So obviously this person does not use the SD slot very often. What else? Audio and face cam. Yep. Oh, by the way, Graham, I've got my new panels. Don't know if you can see them. They're like 600 by 600, 42 watt, diffused 4K. Oh wait, yeah, I showed you them. Sorry about that. Repeating myself there. I do have the older ones, but they're not as nice. I think I might get another 2 of the big square ones. Alright, shut this down. Tony, I wanted the camera down lower, but I haven't got a mount properly. That I don't have the right kind of mount to have it turned around at the moment. I need it to sort of step out about another, probably another 30 centimeters or so. And then once it's stepped out another 30 centimeters, I can flip it around, and then you can get the normal view that you're used to. It's just one of many things that I've got to sort out. So this will now have to go for a clean. Likewise, that DCM board. Good to know that you can swap that connector on the DCM board. Like I said, it is a little bit of a squeeze, but it's not a dangerous squeeze, as it were. Yeah, it's not like you're risking damage. It's just a little bit tighter. Flip in the soft. We'll see if I flip it. It will be 180. It's going to look weird. Here, let's just do it anyway. Transform 180. There, see, because it's got that kind of look backwards type effect, and I find that very unnerving. There we go. Yeah, shorts in winter. It's not very often I get to wear long pants anymore. And that's sad for a guy like me, because I actually very much enjoyed wearing suits. Yeah, Andrew, that's how it feels. When you look at the camera shot at that angle, you feel like you're standing with your head hanging over the edge, and you're going to black out because of the blood rush. That is exactly how I feel. Graham, why are you even in chat here, by the way? Don't you have a bunch of jobs? I mean, don't get me wrong, I'm more than happy to see you around here. Just kind of weird. You do, but avoiding work. Alright, fair enough then. You are right though, it would be the true Aussie experience, I suppose. Though I don't really talk like an Australian. If you want a genuine Australian experience, you really need to, watch Dave Jones. Dave Jones knows how to be a genuine Australian, mate. Okay, nice and clean. Let's write the job number on this. 1450. I have found with this ultraviolet pen, if I need it to survive through the ultrasonic, the trick is to cook it. Not a lot. And this is just at 250. There. And that will now survive through the ultrasonic. And the reason why I mark the job code on these boards is because if I wash 4 or 5 of them, I may not remember which one was which. I mean, obviously I can boot them up and check the serial numbers, but it's kind of easier if you don't have to do that. Obviously you always have ventilation when you're heating up random chemicals. But yeah, I enjoy having this UV marker. I am using the pink marker now. It's like this pink marker. I use that for my, like when I change iPhone screens or batteries or anything that I put in as a product that I've supplied, it gets marked. And it's usually just a teeny tiny dot, but that's all I need. Because then when it comes back I can go, aha, that one's mine. Or, as does happen occasionally, people bring stuff back and say, oh yeah mate, this is the one that you changed for us the other week. And I open it up and it's not, there's no mark there. And it's like, I don't know about that. Not to mention the fact that the brand's wrong and all that sort of stuff. But most people will quickly backtrack and say, oh sorry, yeah, I forgot, I took it to someone else. So no kidding. Alright, so we're going to fix up this. Fortunately that just looks like random junk. It's not critical. But I'll throw that in the ultrasonic as well. Hey there, Jason. Right, temperatures. I use 55 Celsius in my ultrasonic, 5 minutes aside, and then what do you call it? Once it's done in the ultrasonic, I dunk it into just straight deionized water, and then I use a small paint compressor, just the little 3-litre ones, and I blow out all the excess water, and then I throw it into the oven at 120 Celsius or about 125, not that it's that accurate, for 20 minutes. And after that, it's all good. When you're dealing with the boards with the BGA chips, like graphics chips and things like that, you really do need to use the compressor to blow out the water from underneath those chips after you've taken it out. Now I know a lot of people say that they use alcohol after they've dunked it in the water, after it's come out of the ultrasonic. I don't do that, because what happens is when you take this out of the ultrasonic and you put it into the water, you get rid of all the the caustic solution. Then you put it into the alcohol, and the alcohol puts a thin film on these. No matter how much you wash it, you'll end up this thin film that you can't seem to get rid of. And the only reason really that you would use the alcohol bath is to try and reduce the amount of water present on the board after you've done the rinse. But that's why I do the compressor blowout and then throw it into 20 minutes in the oven. So like I'm just using an airbrush compressor like this, and I just sort of blow out the liquid from underneath the CPU, underneath the SMC, the RAM chips. Just give it anything that's got BGA, just try and clear it out. And then 20 minutes into the oven, and it comes out looking factory for the most part. So unfortunately I can't demonstrate that tonight, but there are videos of me having done that. You got yours at 60. I'd say, depending on how gunked up they are, I would find 5 minutes aside at 55, and it depends on what solution you're using. Like like, what cleaning solution are you using? Are you using that Shasitsu or something like that? Yeah, for the oven, whatever you do, don't trust. Well, I shouldn't say whatever you do, but mine's just a pizza oven, but I've got my own controller on it. If you use the bimetallic strip temperature control that most pizza ovens have, you will inevitably end up reflowing your board one way or another, just by pure bad luck or whatever. It happens. It happens. I know it happens because it's happened to me. But yeah, 120 for 20 minutes is usually enough to do it. But you will need to get an external controller or make your own external controller. They're not that hard. They're around. You don't even need a fancy PID one or anything like that. Just something that will switch in and switch out every, say, 5 seconds as required. You don't need high precision. You're not reflowing. It says for cleaning PCBs, is it like ultrasonic cleaning or is it just PCB cleaner? Because you can get like PCB flux off and things like that, but they're not really good for ultrasonicing. I guess the test is when you ultrasonic it, does it turn into a bubble bath? If it does, then it's probably not ideal. If it doesn't, then yeah, no trouble, all good. Okay, it's good. You can use the variac on the oven if you have one. I don't know if mine has a variac. Most of mine were just the ones that I've got. They're just bimetallic strip units. So, and most of the time they work. The trouble is that one time that they don't. I'm paranoid to the point where I'm trying to now put a thermal fuse in there as well, so that no matter what, if the controller fails, it will just kick out if it gets over 150 Celsius. I think I made a video earlier of me doing the modification of the oven, but yeah, pizza oven, I leave the timer, I basically leave everything intact. I put the PT1000 temperature sensor in. It's a platinum sensor, much easier to use those than it is thermocouples. Your normal AVR or Arduino can read them, nothing fancy required because it's just a 1K resistor that changes on temperature. And it's a very linear sort of behavior. Whereas I always found thermocouples to be, you sort of had to sacrifice a few goats to get them to go right. That's probably just my inexperience, because I know thermocouples are industry de facto standard, but for some reason I just couldn't get along with them. Alright. Pedro, I honestly didn't say that. So okay, that's it for tonight. It's almost midnight. I'm going to go and kick back, get some food. I'm pretty happy with how things worked out tonight. Like I said, I'm very happy that we sorted this out. Even though it's a bit of a kludge fix, I'm still happy that it's working out. So zoom in on that. Yeah, I quite like it on the white. I definitely think I'll keep with that. Yeah. The little hyphens are just there to indicate that nothing's connected on the other end. Doesn't always work. But yeah, for me, the biggest thing of this was the fact that now it gives me a data link so that it can, show up on screen. Having it on screen here has been invaluable for me in the last couple of days. So, alright, I'm out of here. You all take care. I'll see you next time.